Hello students, welcome back in the series of lectures on vector differentiation. This is part 3. Earlier what we have done in part 1 and part 2 is how to find acceleration and velocity of a moving particle in a particular direction along a particular curve. We also done discussion on gradient, divergence and curl of a vector function. Remember, gradient is calculated for the scalar and curl and divergence is calculated for vector function. We also done discussion on their physical significance. Now, after this, the next we are having is directional derivative, one of the most important topic in vector differentiation. So, in today's lecture, we will discuss what is directional derivative, what is physical significance of it, and how to calculate it. At last, we also discuss some problem based on it. So, let us start. Now, directional derivative. Basically, what is directional derivative? Basically, the directional derivative means what? The directional derivative for a function along a particular direction gives the rate of change. Means it is a rate of change for a given function in a particular direction. In a particular direction. It is also defined as rate of change at a particular point in a particular direction, or instantaneous rate of change in particular direction. For calculating the directional derivative, we must have a scalar surface, or we can say a multivariable function, and we must have a direction d. So simply, if I am having a surface phi and I need to calculate its directional derivative in a direction d, it means I am supposed to find rate of change in this surface along the direction d. It is calculated on the basis of the gradient of the surface. Simply, as we can see, the directional derivative is the dot product of d cap and gradient of the surface phi, that is the given surface. Means first of all we need to find the gradient of the surface as we have done in earlier classes and do its dot product with d cap. What is d? D is the direction vector, that is the direction in which we need to find rate of change, and d cap is defined as vector d upon vector d magnitude. Means whatever this expression gives us is known as the directional derivative for the function phi in the particular direction d. Remember only two things here, that we need to find the gradient of that surface phi, that is del phi, and we will do the dot product in the direction d. So when we are getting a problem from the directional derivative, first of all we have to decide what is the function, that is the surface phi. The second thing, we need to decide what is the direction d. After these two things, we will find the del phi, that is the gradient. Then after that, we will do the dot product of del phi with d cap. Remember, d cap is the unit vector here, which is defined as vector d over vector d magnitude. Let us see how the problem comes from this concept. The question: find the directional derivative of this surface at the point 0, 1 in the direction of d. So as I told you, we have to decide two things. This is the surface as it is a scalar quantity. So this is what? Phi, and direction is I plus j. So we have decided what is phi, that is what is the given function or surface, and we have decided what is the direction d. Now as I told you, directional derivative is what? Del phi dot d cap. So first of all we need to find del phi. So del of phi, so simply we are having del is a vector differential operator as I discussed in earlier classes. It is I into del over del x plus j into del over del y plus k into del over del z into whatever the given surface x plus y over x minus y. Do the product. I as it is del over del x of x plus y minus upon x minus y plus j into this product plus k into this product. Now I need to do the partial derivative for the respected function with respect to, for first one x, for second y, for third z. This derivative for x, it means y and z is constant. In numerator we are having xy, in denominator also, so I am going to apply the division rule. So x minus y whole square, x minus y as it is, x plus y derivative for x will be 1, minus x plus y as it is, its derivative for x is 1, plus j time, once again the same rule I am applying, plus k times derivative for this function for z. Since it is independent of z, so xy will be constant, or we can say we are going to find the derivative of this expression for z, and it is having only x and y, so it taken as constant, and derivative of a constant will be 0. Simplify, I will obtain this. So this is what the del phi. Now if you see that we need to find it at the point 0, 1. It means this is the point x, this is the point y. So I need to put x equal to 0 and y equal to 1 in whatever del phi I obtain. So x is 0, so this will become 0, y is 1, so minus 2 upon 0 minus 1 square plus 1, that is minus of 2i is the del phi for this given surface. So finally, directional derivative of phi in the direction of d, we are having del phi into d cap. Remember, these are not anything, this is what a simply bracket, a closed bracket. Del phi we are having minus 2i, d is given as I plus j. So d cap will be what? This is what? It must be d cap, it is not vector d. D cap is what? Vector d over its magnitude. Magnitude is what? Coefficient of I square, coefficient of j square plus coefficient of k square. Simplify. So this will be root 2, take it outside, I to I, j to j, k to k. This is the way of doing dot product. So minus 2 into 1 is minus 2, j is not here, so 0 into 1 is 0. So finally I will get minus 2 over root 2, or we can say minus of root 2. So this is the directional derivative for the given surface phi in the direction of d. It means this is the rate of change of phi in the direction of d. So this is how we will solve the problem based on directional derivative. Let us see one more problem. Now this time they are given that this is the surface, that find the directional derivative of this surface at the point P in the direction of PQ. Here vector is not given, they are given as PQ is the direction, when P and Q is given in terms of a points. So firstly we will find the D. D is what? Given as PQ direction, and it should be Q minus P. Q is what? 504 minus 123, that is P. Subtract. So 5 minus 1, 4, 0 minus 2, minus 2, 4 minus 3, 1. Now write in terms of ijk, so 4 times I, 2 times j, 1 times k. So this is the given direction. Now first of all we need to find del phi. What is phi here? This is the surface phi. So del dot phi, del into phi, do the product for each function. Now its derivative for x, it will be 2x, 0, 0. For y, 0, minus 2y, 0. For z, 0, 0 and 4 of z. So this is what I am getting del phi. Now I need to put this point in del phi. So x is 1, y is 2, z is 3. Put these value in this expression. So I will get 2i minus 4j plus 12k. This is the del phi, not the directional derivative. This is what del phi. Now next. So finally del phi, once again gradient dot d cap. It should be d cap, it is not vector d. Once again del phi, and d cap is what? Vector d over its magnitude. So 4 square plus minus 2 square plus 1 square. So this will be 16 plus 4, 20 plus 1, 21, root of 21. Now do the dot product, I to I. So 2 into 4 is 8, minus 4 into minus 2 plus 8, 12 into 1 is 12. I into I is 1, j into j is 1, k into k is 1. That's why ijk is not present on it. Finally, 28 over root of 18 is the directional derivative for the given surface in the direction of the vector d. Let us see one more example. This time find the directional derivative for this one at this point in the direction of this one. I suggest to all of you, and just pause your slide for a moment and try to find the directional derivative for this function by yourself. And at last try to match your answer, and if you are not getting correct answer, just see where the mistakes occurs. So let us see what the solution we are having. Phi, and it will be d. Simply del phi firstly. So product, its derivative for x is 1 plus 0 plus 1, y 0 plus 1 plus 0, z 0 plus 0 plus 1. So this is what del phi. Now I need to put the point, but it is free of x, y, z. So it is as it is becomes del of phi. So finally directional derivative, once again I am repeating, it should be d cap, not vector d. So do the dot product the same, 1 square plus 2 square plus 1 minus 1 square, it will become root of 3. Product I into I is 1, j into j is 1, k into k is minus this one due to this. So 1 cancel, 1 over root 3. So 1 over root 3 is the directional derivative for the given surface in the direction d. So this is all about what the directional derivative we are having. Try to understand it critically, not getting in once or second or third attempt. Try to see it repeatedly. Still facing any doubt, you can ask the same in your comment section. Now, there are some assignments problem we are having. In the first question, we need to find directional derivative of this one at the point this in the direction of this. So this will be phi, this will be point, and this will be the vector d. So simply apply the concept that we have done and you will get your answer. Another, find the direction in which the directional derivative of this function at 1 comma 1 is 0. Most important question this one. Here they are not asking the directional derivative. What they are asking, we need to find the direction in which this functions having directional derivative as 0 at the point 1 comma 1. So first of all you need to find del phi, that is this is the given phi, and we need to find d. So del phi, put the point and then analyze del phi, that to whom should it multiply that it will become 0. The last one. Find the directional derivative of del of f at this point in the direction of this much where f is given as this one. We have to find directional derivative of this function. So this is the phi. It is given in terms of del. It means first of all we have to find del of f. F is this one. Whatever we are getting, do its dot product once again with del. So this will becomes the given surface phi. Then find that gradient. Point, put the point, do its dot product with d cap, where d is this one. So try to solve these questions, and if any confusion or any issue occurs, you can directly put it in the comment section. Remember one thing, when you are putting any doubts in the comment section, it's better if you put that snapshot from this video lecture in that comment so that it's easy to understand what you want to ask. So thanks for watching, and please make your short note on the basis of these lectures. Thank you very much.